We see a future where intelligence is a utility like electricity or water, and people buy it from us on a meter and use it for whatever they want. Now, that is a massive, bold vision from OpenAI CEO Sam Altman, and honestly, it perfectly sets the stakes for what we're going to explore today. We are literally watching artificial intelligence evolve right before our eyes, shifting from this novel kind of experimental software tool into a fundamental, everyday utility. So if you're looking to cut through all the noise and understand the actual mechanics of our rapidly changing world, well, you're in exactly the right place. Welcome to this explainer. We're going to look past the endless AI hype cycle, you know the one, and map out exactly how this technology is fundamentally rewiring our industries, our labor markets, and honestly, our daily lives. All right, let's dive into this. I actually want to start by posing a question that might seem, well, a little out of place for a discussion about cutting-edge tech. Are we just building a better steam engine? Just keep this historical question in the back of your mind as we go through this explainer, because it's going to propel our entire narrative. We really need to figure out the difference between the clumsy, superficial adoption of new tech and true, deep systemic integration.
Section 1. AI as the new electricity. To answer that question about systemic integration, let's zoom out to the macro level first. Think about the traditional software model we've used for decades. It meant paying for expensive subscriptions or owning and maintaining these really complex, heavy-duty hardware systems. But the AI utility model, it flips that entirely on its head. Just like you don't need to own an entire power plant just to turn on a light bulb in your living room, businesses and individuals aren't going to need to own advanced hardware. You'll just plug right into AI services through the cloud whenever you need help, maybe for coding, research, data analysis, and you'll pay on a meter. You are strictly paying based on exactly how much intelligence you actually consume.
Now, making something as unbelievably complex as AI feel as simple as turning on a tap, that requires a staggering physical reality behind the scenes. We're talking about massive sprawling data centers that act like huge college campuses, where thousands of workers build and maintain the systems. It takes specialized computing chips, absolutely immense electricity demands, and these giant mega partnerships between heavyweights like OpenAI, Amazon, NVIDIA, and SoftBank just to foot the bill. The whole goal here is to make AI instantly accessible at a massive scale, rather than having it controlled by just a handful of companies.
Moving on to Section 2, the steam engine lesson.
So let's take a quick look back. In the 18th and 19th centuries, we had steam, railways, and mechanization, right? Then, from the 1940s to the early 2000s, the Third Industrial Revolution gave us computers, digital systems, and the internet. And now, from the 2010s to the present, we've crashed right into the Fourth Industrial Revolution. This is driven by the convergence of the physical, digital, and biological realms. Think AI, robotics, quantum computing. But here is the absolutely crucial point derived from our sources. The sheer speed of today's tech convergence is entirely unprecedented. It is vastly outpacing the speed at which our social institutions and our laws can actually adapt.
And because it is moving so unbelievably fast, people are making a classic historical mistake. Think about when electricity first became viable for industrial use back in the late 1800s. Early factory owners did what seemed totally logical. They swapped out their massive steam engines for shiny new electric motors. But they changed absolutely nothing else. They kept the exact same rigid, multi-story buildings, the same complex, dangerous systems of belts and pulleys that were designed around one single central power source. The productivity gains? Pretty marginal. It wasn't until innovators realized, wait a minute, we can use dozens of smaller motors to completely redesign our factory layouts, giving us the modern single-story assembly line, that the real manufacturing revolution actually happened.
And you know what? Today, we are seeing that exact same clumsy transition play out. Walk into most organizations right now, and you're going to find them doing the digital equivalent of swapping the steam engine for an electric motor. They're taking incredibly advanced AI tools like ChatGPT or Claude and using them just to write emails a bit faster or maybe to summarize a Zoom meeting. Now, don't get me wrong, those are useful applications, but they are fundamentally about doing the same old things just slightly better. It is literally retrofitting AI into rigid existing workflows without seeing the bigger picture.
Which brings us to Section 3, implementation over benchmarks.
To truly understand how to break out of this trap, let's zoom in on the organizational level. Whenever new AI models drop, there's this stark contrast in how they're received globally. The Western tech community, for instance, often falls right into the trap of evaluating the artifact. They obsess over benchmark scores, things like MMLU, which tests a model's massive multitask language understanding, and they sit around debating, well, how good is it compared to the last version? Meanwhile, in China, the focus is heavily on deploying the tool.
Rather than arguing over benchmarks, manufacturers, financial institutions, and healthcare organizations are just rapidly prototyping diagnostic tools and quality control applications. One culture asks, how good is it? The other asks, what can we build with it right now?
MIT's Andrew McAfee sums this up perfectly. He says the true differentiator is systematic integration. So what you should really take away from this is that your competitive moat isn't built by having access to the best AI model. Because guess what? Everyone has access to the models if they're willing to pay the meter. The real advantage goes to the organizations that fundamentally redesign their entire organizational structure. They're the ones asking what entirely new products and services become possible when every single employee has an AI collaborator working alongside them at machine speed.
Let's pivot to Section 4, Transforming the Human Workforce. We've talked about the macro utility grid, we've talked about organizational layouts, but let's bring this right down to the level of the individual worker. Hold on to this number, because it's absolutely staggering. According to a McKinsey statistic cited in our sources, nearly 100 million workers globally will need to transition their careers and find completely different occupations by the year 2030, all due to automation and this AI shift. To put that into perspective, 100 million people is roughly the entire population of Canada and Italy combined. So the AI revolution isn't just about jobs being destroyed. It is about a massive, global transition of human roles.
And we aren't just talking about software in an air-conditioned office here. We are talking about human-machine cooperation out in physical spaces, like modern warehouses. Smart machines, drones, and automated platforms are increasingly going to handle the routine, repetitive tasks and the heavy lifting. Now, this doesn't mean humans just disappear from the equation, but it absolutely means human roles are being entirely redefined to complement whatever the smart machines are doing.
So you're probably wondering, how do we actually thrive in this new environment? Well, the workers who will be the most competitive, regardless of what specific industry they're in, have to cultivate a very specific set of future skills. First up, social and emotional intelligence. These are the things machines still really struggle with. Second, advanced cognitive abilities. We're talking critical thinking, decision-making, and frankly, statistical understanding, so you can actually interpret all the data the AI generates. And finally, continuous digital adaptability. You have to be able to constantly adjust yourself to new digital environments and new ways of working, because this technology is not going to stop evolving anytime soon.
Okay, Section 5, Algorithms and Labor Rights.
But let's be real for a second. Individual skills aren't going to be enough if the system itself is fundamentally exploitative. We really have to ask, who decides what tasks machines do, and who is managing the humans that remain? The explosive rise of the gig economy, powered by algorithmic management on platforms like Uber or Deliveroo, has introduced some entirely new vulnerabilities. These models often feature fragmented duties, really vague pay structures, and much weaker obligations between the employer and the worker than traditional jobs. It raises some profound questions about power dynamics and occupational safety when your boss is essentially an opaque algorithm that is programmed to prioritize cost-cutting above all else. To protect workers from this, our sources highlight an incredibly urgent need for what's called algorithmic transparency. But listen, this doesn't just mean staring at a giant wall of complex code. Companies usually protect that as a trade secret anyway. True transparency means knowing exactly who these algorithms are targeting. It means understanding what specific variables are being inputted, like are they using data on race, gender, or socioeconomic status to secretly calculate performance or pay. And most importantly, it means workers absolutely must have the legal right to receive clear explanations for automated decisions and the right to challenge them. The sheer complexity of machine learning can never, ever be used as an excuse for human rights violations or opaque, unfair management.
At the end of the day, the true differentiator isn't the technology itself, it's our willingness to adapt to it. So, as you look at your own workflows, your own business, and your own personal skill sets, you have to ask yourself the big question. Are you fundamentally redesigning your future? Or are you just buying a slightly better steam engine?